in this problem we have natural log, we have a logarithmic equation again. Natural log of 3x minus 5 equals to natural log of 10 minus natural log of x minus 2. In this case, we don't have the same situation that we had before when you have a single log. This one is a single log, but this one is not. So, but is there a way that we can write this as a single log? Yes, we condense this expression, right? The right side of the equation. So what I'm going to do here is rewrite natural log of 3x minus 5 equals to natural log. Since these two are, this one is subtraction, so we can condense it as a natural log of 10 over x minus 2, right? We have that rule of condensing. From here, since it have the same natural log in both parts, and like I said, logarithmic logarithmic function is a one-to-one function, so we can just ignore natural log and say, okay, then 3x minus 5 equals to 10 over x minus 2. In order to solve this equation, we need to multiply both sides by x minus 2. Since we multiply by x minus 2, we have to make sure that x is not 2. Because when x equals 2, this is 0. So that will be not valid, right? So we're assuming that x cannot be 2. Okay, so we continue. In this side, we're going to use FOIL. We have x times 3x is 3x squared. X times negative 5 is negative 5x. Negative 2 times 3x is negative 6x. And negative and negative is positive 10. In this side, we cancel the x minus 2. That's what we multiply that by. So it's 10. So we're going to here, since this 10 is the same as this one. Oh, let me combine like terms first. This is 3x squared. These two together is 11, negative 11x plus 10 equals to 10. So subtract 10 in both parts. So you have 3x squared minus 11x equals to 0. We can solve this equation different ways. You can use quadratic formula, but we can also factor. And factoring is always easier. You know, all the time where you can factor instead of using the quadratic formula, do it. So as a common factor, we have x times 3x minus 11 equals to 0. From here we have then the x equals 0, or 3x minus 11 is equal to 0. So one is x equals 0. The other one, we add 11 in both parts. You have 3x equals to 11. So x is divided by 3. X is equals to 11 thirds. So I think I already explained to you in the previous problem that when you have you're solving a logarithmic equation, we need to check. It's part of the solution of this kind of equations is checking. So we have to check for external solutions. Right away you can tell that x equals 0 is not gonna work, because once I put 0 here, I'm gonna have 3x minus 5. 0 minus 5 is negative 5, and logarithmic equation, function, domain is always positive, all the positive numbers. So 0 doesn't work. 0 is extraneous. So the only one that we need to check is 11 thirds. So I am going to just raise this a little bit here. I'm going to put it in this side. X cannot be 2. Okay, so I'm going to do the checking part here. Okay. Let's replace 11 thirds where x is, and we always do it in the original problem. Natural log of 3 times 11 thirds minus 5 equals to natural log of 10 minus natural log of 11 thirds minus 2. Okay, so here we have 3 cancels 3, 11 take away 5 is 6. So natural log of 6 equals to, this one I'm going to use the rule 10 over 11 thirds minus 6 thirds, because 2 is 6 thirds, is 11 minus 6 is 5. See what I'm doing right there? 10 over this answer right here, which is 5 thirds. Then from here, natural log of 6, remember this, we're checking here, right? This is a question mark. We are checking if these two things are equal to each other. So I'm going to put 1 here to complete the fraction, and you have 10 times 3 on top, natural log of 30, and 1 times 5 is 5. So natural log of 6 equals to natural log of 6. So it works. Number 19.